2016 Discovery Education 3M Young Scientist Challenge. Our final finalist is Rohit Mittal from Rochester Hills, Michigan. Let's give him a warm welcome. All right, my friend, you're up. Good luck.
All right, thank you. Good morning, everyone. My name is Rohit Mittal, and I will be presenting my mat innovation that is used for mounting ceramic substrates in emission control devices, such as catalytic converters and particulate filters. On the left is a converter schematic showing the substrate, the mat, and the metal shell housing. Using the force balancing equation, we can see that the mat has to provide enough compressive force to counter the back pressure from the exhaust and the acceleration forces that the substrate will experience. Yet it has to do so while not exceeding the isostatic strength of the substrate as it's being compressed to achieve that holding force. So you may be thinking, 3M already has a vast portfolio of mats, so why do I need to invent a new one? In a previous project, which I submitted for the Young Scientist Challenge in my video, I had designed a triangular cell filter which had much higher surface area and lower back pressure than the corresponding square cell filter, which is actually in production today. So my prototype was built here, and testing confirmed my analysis results that use of this filter could save the US millions of gallons of fuel a year. So why isn't this filter already in production, you ask? Well, in the past, extrusion, the removal of these triangular shapes of these cells and wash coating them with the catalyst has been difficult because the wash coat would plug the channels of and the corners of the channels, and that would reduce surface area. These issues are all resolved now, but what remains is the strength of this substrate. It has stress points at the corners, and so it has significantly lower isostatic strength than the other filters, and it cannot withstand the canning process. And hence there is a need for an innovative support mat. I hypothesized that my new design would fix all of these shortcomings and significantly reduce the pressure that is put on the substrate. So to solve my problem, I first did a case study to evaluate the performance of currently available mats from 3M and other suppliers. Using the force balance equation, I calculated the minimum mat pressure that would be required, and I calculated the peak pressure that the substrate would experience using these peak pressure curves. Out of the 15 or so mats that I investigated, only 5 passed my hypothetical case study, which was already less severe than the actual requirements because otherwise no existing mat would have passed. The mats that failed either did so due to high peak pressure or low holding force. Now, with these down-selected mats, I tried to identify all the common features that make them so good. It was obvious that non-intumescent mats or hybrid mats with low binder content were desirable. It was also obvious that for the hybrid mats, the vermiculite content should be low, and the fiber type was always best as polycrystalline. As is obvious from the force balance equation, a higher coefficient of friction is desirable. By varying the coefficient of friction, I could see how the minimum holding force varied, and a lower holding force requirement means that a substrate can be canned at a lower peak pressure, and that means that it's going to avoid all possibility of substrate damage. I came up with 2 ideas to increase the coefficient of friction. The first was to introduce micro-sized silica particles during manufacturing, and the second was to add a texture to the surface of the mat. Finally, a prototype was created using my required characteristics. There's a shell side and a ceramic side. I decided to keep the 3M vermiculite on the ceramic side based on heat transfer, so it heats up faster and can expand faster. I used polycrystalline fibers from 3M to make this sample, and I also fixed these silica particles on the surface of my mat using 3M Super 77 adhesive. And finally, it was time for the defining moment. It was time to see if my new mat, designated SPR 142 by 3M, could pass the new tests. The peak pressure data, as shown there, was just marginally better than currently available mats. However, the coefficient of friction showed significant improvement. It's almost double what you'd see in currently available mats. So using this new data, I recalculated the safety factor and the holding force and the peak pressure. And as you can see, with a constant safety factor, about 1.12, similar to the first mat, 1.15, the peak pressure reduced significantly.